miss the test of a straight to life. Don't miss the conversation. I'm searching for the sun tonight. I'm trying to love the station.
Hi everyone, so today I'm gonna explain to you guys how to make the robot driving straight in the auto selections of the VEX IQ competition. So I have made the video like this, but it is on a little bit advanced code language. So today I'm gonna make it into block version, so beginner also can use that. So first you're gonna add two individual motors. So it shows your drivetrain. So you're gonna select the part and you're gonna decide which is the left or right motor. And you will always have to set one motor to reverse when you set the drivetrain like this. Okay, for first you're gonna make a block that calls move and have two inputs that call left velocity and right velocity. So I'm going to define motor left move to motor left velocity and right velocity. So you're gonna set motor left velocity to left velocity and set motor right to right velocity, and you're gonna spin motor left and motor right forward. Next, you're gonna define another block that called Gyro drivetrain. So we're gonna have three inputs. The first one is called distance, and in our country the most famous unit for the distance is centimeters, so we're gonna convert the distance to centimeters. The second input is the velocity. The third one is the kp, and the last one is the boolean equal stop. So this thing helps you to stop the motor when you drive enough distance or not. So example, when you want to drive straight into a wall after you drive enough distance, so you can set this to false. So you're gonna define this Gyro drivetrain. The first thing, I'm gonna make a variable called wheel diameters in centimeters. So I'm gonna set wheel diameter in centimeters to 10.16. The next one, I'm gonna make a second variable called p value. So the p value is equal to 3.14. Next, you're gonna make another variable called wheel curve in centimeters. So we're gonna set this variable to wheel diameters times the p-value. Okay, so the second step, you're gonna set rotational rotation to 0 degrees. So this thing helps you reset the rotation after every move. Second, you're gonna set left and right motor position to 0 degrees. So the next one, we're gonna set if distance in centimeters is bigger or equal to 0, we're gonna have another variable called direction. So we're gonna set the direction to 1, and if else, that means the distance is less than 0, the direction is gonna be -1. So we have when the velocity or the distance is negative, so the robot will drive reverse, and when it's positive, the robot gonna drive forward. Next, we're gonna have a more variable called target distance. So we're gonna set the target distance into the APS of distance in centimeters. Next, we're gonna have another variable called target degrees. So this target degrees will equal to the target distance divided to wheel curve in centimeters n times 360. The next step, we're gonna have the new more variable is called deadband degrees. So we're gonna set this to 1. And we're gonna make another variable called max correction factor. So we're gonna set this max correction factors to 0.4. Also, the next step, we're gonna repeat until the average depth is also the variable that I said is bigger or equal to the target degrees. So we're gonna repeat until the average degrees is bigger or equal to the target degrees. So we're gonna have the set the variable called left position. So we're gonna set the left position to the motor left position in degrees, and we're gonna set the right position to motor right position in degrees. So we're gonna have one more variable called average degrees. So set this thing to the right motor position plus left position and divide it by 2. Next, we're gonna have one more variable called heading. So we're gonna set this heading into the operational rotation in degrees. Next, we're gonna have one variable called the error. So this error gonna set the error to 0 minus the heading. So if the ABS of error is bigger or equal to the variable I call the deadband, then we're gonna set the turn to the arrow times kp. Next, we're gonna set the more variable called base speed. The max correction is speed PCT. So we're gonna set the base speed into speed specificity times for the direction. And we're gonna set the max correction into the ABS of base speed times for max correction factor. So if the ABS of turn is bigger than the max correction, then set turn into max correction times turn divided to the ABS of turn. And I'm gonna set the left speed, so it's another variable I make, and the right speed to base speed. The left speed gonna be base speed plus turn, and the right speed gonna be base speed minus turn. So if the left speed is bigger than 100, then we're gonna set the left speed to 100. And if the left speed is less than negative 100, so we're gonna set the left speed to negative 100, and it's as same as the right. So next we want to move for the right speed and left speed. This is the code that we have defined at the start. So if we wait if we set the motor stop after we drive enough distance, then we're gonna stop the motor, and after before that we're gonna wait 0.01 second just for it to like taking back the direction of the original. Okay, so it's end of our code. So I'll give you the file of this code in the description below, so you can have it and use it for your robot. Thanks for listening.